Section 6.6 is graphing inequalities in two variables. So up till now we've been using inequalities with one variable, an x or an r or something like that. Now we're going to go back to our two variable graphs, but we're going to use inequalities. So let's go back to graphing how we graph an equality with two variables. So this is a simple linear equation. So to graph this with two variables, y equals 2x minus 1, we can set up an xy table if you'd like. You can also, remember, use our slope-intercept form. So I think I'm going to do that. So setting up a graph, you obviously are going to need graph paper for this homework and for these notes. So pause if you don't have graph paper and get some. You can always print it off on the computer. So starting at -1 with a slope of 2, excuse me. Oh, that's terrible. Starting at -1 with a slope of 2, up 2 into the right 1, up 2 into the right 1, and that's my graph of y equals 2x minus 1. If I had used my table of values and plugged in -2, at -2 I would have gotten 2 times -2 minus 1, which is -5, -2, 1, 2, 3, 4, 5. That looks pretty good. At -1, 2 times -1 minus 1 is -3, -1, -3, 0, -1, 1, 1, and 2, 3. So 1, 1, and 2, 3. So that all looks good. And again, there's my line. I don't know why I keep losing things. All right, so that's graphing an equality with two variables. Now we're going to talk about inequalities. So the first thing we have to talk about is that when we have a line in the plane, it divides the plane into two regions called half planes. So for example, if I have an xy ordered pair, and if I have a line in the plane, let's say it's one similar to the one I just did, this divides the Cartesian plane into two half planes. One of the half planes would be up here to the left. The other half plane would be down in this section. So when we add our greater than less than, our solution is actually going to be an entire half plane. So let's take a look at how that's going to work. Ordered pairs that satisfy an inequality. Let's start by rewriting this inequality, and I'm going to write it temporarily as an equation, so that if I subtract 3x from both sides and divide by 2, that's my equation. So let's take a look at this. Wow. I don't know what's going on with my pen, my stylus. Let's see if I can get it to work a little better. Okay, so plus 6, 1, 2, 3, 4, 5, 6, with a slope of down 3 and to the right 2, would give me something like this. Now, go back and look at our inequality. Remember when we did inequalities with one variable, less than or greater than was an open circle, greater than and equal to or less than and equal to was a closed circle. When we do a line, greater than and less than is going to be a dotted line, indicating that it is a boundary but not included. Greater than and less than is going to be a solid line. So this is just less than. We don't want to include these points, so I'm going to put a dotted line here. And that separates my plane into two half planes. So let's look at some of these and see whether or not they are solutions. So let's do a table. I'm going to go ahead and do a table using my original equation, 3x plus 2y is less than 12, and see whether it's true or false. So when we have an ordered pair, do it this way. Let's say we have x is 1 and y is 6. So I've got 3 times 1 plus 2 times 6 is less than 12. We can see that that is false, because that would be greater than 12. Let's say I have 3, 0. So that would be 3 times 3 plus 2 times 0. That is less than 12, so that's true. Let's plot those. 1, 6 would be up here. We said that was false. 3, 0 would be here. And we said that was true. Try 2, 2. I'm going to run out of room here, sorry. All right, let me try it again. I can't get rid of my... All right, here we go. Now I'm back in business. Sorry about that. Let's try 2, 2. And that gives me 3 times 2 plus 2 times 2. That's still less than 12. Oops, 2, 2 is there. So that's true. And if I put in 4, 0, it would be right on the line, and that's false. So the equations on this side, or the ordered pairs on this side, are true. So this is the half plane that I am going to be graphing. So my graph for this equation is everything up to but not including this line and on this side of the line, or the left-hand half plane. Let's try another one. These two are special cases, single variables. So let's look at y is greater than or equal to negative 4. First, we need to know where y equals negative 4. So 1, 2, 3, 4, that's negative 4 on the y. It says just greater than, not equal to, so I'm going to use a dotted line. And hopefully we know that y will be greater than negative 4 if I go up, because on the y-axis, the numbers that are larger go up. Let's try this one. Erase. Okay, so x as a single variable is to the right. So x equals 3 is to the right. So I want this to be greater than and equal to 3. So I'm going to use a solid line. That's the line x equals 3. I want it to be greater than and equal to 3. So x is greater than as I move to the right. So we're graphing a range of solutions rather than a single solution, since we have an inequality. Okay, let's try this one together, and then I'm going to give you one on your own. So the first thing I want to do is rewrite this into my slope-intercept form. So I'm going to add 2x to both sides. So I get y is greater than or equal to 2x minus 3. I'm going to come over here and look for my boundary line. So negative 3 is my y-intercept. My slope is up 2 and to the right 2. Greater than and equal to means I want a solid line. And now I've got to figure out which side is the correct half plane. So let's pick a point and test it. Let's go ahead and pick 0, 0, because it's easy to plug in. 0 is greater than or equal to 2 times 0 minus 3. 0 is greater than or equal to negative 3. That's true. Remember, if it's true, that's the half plane that is going to have all of my solutions. So the process is solve the equation so we can graph the border line, put the border line in, decide whether it's dotted or solid, then pick a point to test. If the point is true, I graph that side. If the point is false, I graph the other side. Let me give you those steps. Come on. Well, let me go to the next slide. For some reason, it's not erasing. Okay, so let's go ahead and write those steps down before we do this equation. Step 1 is rewrite the inequality into slope-intercept form. It's our y equals mx plus 2. Graph the boundary line. So that's dotted if it's greater than or less than, solid if it's greater than and equal to, less than and equal to. 3. Pick a point on one of the half planes, in other words, not on the line, but next to it. If it's true, I'm going to shade that side. If it's false, I'm going to shade the opposite side. All right. So get all that written down, then we're going to try this next one. So try this one on your own using the steps we just talked about and then come back. Okay, first, it's already written in y equals mx plus b, so I'm good. I'm going to graph the boundary line. My y-intercept is -3, my slope is 1, so up 1 and to the right 1. I'm going to use a dotted line because it's less than or equal to. I'm going to pick my test point. Again, I'm going to pick 0, 0 because it's nice and easy to work with. So if I plug in 0, 0, I get 0 is less than 0 minus -3. 0 is less than -3. This is false. 0 is not less than -3. So that is not a solution, so I have to shade the other side. Okay? All right, let's do one word problem, and we'll do a couple more of these in class before I let you start on your own. So Rosa sells TV advertising in 30-second and 60-second time slots. If there are 10 minutes available, how many 30-second and 60-second slots can she sell? I'm going to use X for my 30 seconds and Y for my 60 seconds. All I have is 10 minutes, so whatever I sell has to be less than or equal to 10. The 30-second slots is only half of 1 minute, right? So half times the number of 30-second slots plus the number of 60-second slots should give me 10 minutes. So let's rewrite this, subtracting the 1/2 x from both sides. Go ahead and graph this. I'm going to graph it over to the side because I know that I've got to go up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 1 to the right 2. I'm not going to be able to get all the way down to my graph. This is and equal to, solid line. And it says y is less than or equal to. So let's pick our 0, 0. If I plug that in, 0 is less than or equal to 10. That is true, so I need to shade this way. So any ordered pair in here is going to give me a possible combination of 30-second and 60-second time slots. All right, that's it for the video. We are going to define a little bit more of this together when we get together, but that's all for the notes.